Test, test, test. Test, test, test. Test. Testing the microphone. Hello, testing the microphone. Testing the microphone. Testing the microphone. Hello. How you doing, Aquino? What you need help with? I'm just drawing a sun. Some grass. If you guys have any questions, just let me know. I can answer. I have the worksheets we did in class today. I can answer some old stuff. If you guys have any questions, just let me know. I can answer. I have the worksheets we did in class today. I can answer some old stuff. If you guys have any questions, just let me know. I can answer. I have the worksheets we did in class today. I can answer some old stuff. 7C. If you guys have any questions, just let me know. I can answer. I have the worksheet. Alright, let's see. 7C was on which worksheet? Calculating using motion graphs. Well, let's see if, hold on. Supposed to be able to documents. Here we go. Alright, 7C. So we've got our bus, we've got our graph. Look at accelerating at this rate. How long would it take the bus to speed up at 100 meters per second? So, let's see. So we're at what? DE? Is that what we're looking at here? So if the bus continued accelerating at this rate, what would speed be at 45 seconds? How long would it take to get to the speed of 100 seconds? So this is basically the same question, just doing it with different formulas. So when you look here, we've got, where'd my mouse go? Segment DE. So this segment right here, segment DE. When we look at the slope, remember we've got a speed and a time, so our slope is our acceleration. So if the bus continued accelerating at this rate, how long would it take to speed up to 100 meters per second? Well, we got to do 7B first because that's going to tell us how to do it. And 7A actually, so let's just start back here. Calculate the bus's acceleration. So to find the slope, we do our average rate of change over time. So let's see, where am I? We want to do our slope, which is y2 minus y1 over x2 minus x1. So we look here, we've got our y going over at 5. And then our y down here is 0. Then our x2 over here is 21. And our x here is 18. So that's going to give us 5. Man, I cannot write today. 5 over 18, 19, 20, 21, 3. So 5/3, which is equal to, I don't have a calculator. 1.7. Okay, so 1.7, and our units are meters per second squared. Okay, cool. So 7b, if it continued at that accelerating at the rate, what would its speed be at 45 seconds? Okay, so it's 45 seconds. So that's now our speed. Remember, our speed is our y-axis. So if we're going that entire thing, we can find out what it's going to be just plugging it into either the slope formula, or plugging it into the speed, distance, time formula. So we're looking here. I want to do the math one, y equals mx plus b. Here we know our... Wait a minute. Am I doing this? Am I making this harder than it should be? So at 5 seconds, our speed, oh, I'm sorry. Our speed is 5. Our distance is... Why am I making this so hard? Aquino, you've stumped me, dude. Apparently I was not ready for this. We have our slope. We can plug it in, find our time. And using our time, we can do our speed and distance. Okay. I literally did all this morning, and I don't know why I'm blanking. Hold on, give me a second. Alright, now I gotta go find the key I made. Apparently I'm having trouble today. See, even sometimes I forget how to do that. So you gotta look it up. Can't find the key I made this morning, and I somehow am drawing a blank now, so we are going to look it up and figure it out together. All right, Akino, I'm going to come back to you. I don't know what I'm doing, but apparently I have forgotten it. I don't want to tell you the wrong thing, so I'm going to have to tell you tomorrow. That's time. That's not what it's asking. I know. Yeah, I'll get back to you tomorrow on it. So number 3 on calculating using motion graphs, this guy right here. How long will it take each runner to run 100 yards? Show the equation you use. So it's just asking for the equation, so Akino that just provided it for you. So how long, that's time. And let's see. So time is equal to distance over speed, because remember, we have speed equal to distance over time, or our triangle DST. Oh, wow. I'm having trouble today. Having trouble. D, S, and T. So we cover up our T, and we can see that it is D over S. So we're going to time equals distance over speed. So you have your speed for your runner, and then your distance is 100 yards, so you plug that in, 100 over your speed, and you get your time. Formula challenge. Okay. I can pull that up. Hold on. It's formula challenge. Which one, Marilyn? The first one, number 1. Okay, what do the following units represent? Or Goldie Goldfish? So number 1 or the first actual problem? So are you talking about this guy? Or are you talking about this guy? All right, Goldie the goldfish is a speed swimmer, going quick, loves to race around the park's pond, which is 0.5 miles around. If she can swim 20 laps around the track in 2 hours, what is her average speed? Okay, so she's doing 20 laps in 2 hours. Okay, so we're going to set this up. We're going to look here. We are going to do 20 laps, which is 0.5 miles each, right? So we need to figure out how far that actually is. So we're going to do 20 times 0.5 to give us 10 actual miles. Okay, so she did 20 laps, and it's 0.5 miles a lap, so half a mile pond. She does 20 of them, so she ultimately does 10 miles. Okay, so we need that. Now, it says she does it in 2 hours, and what is her average speed? So we have our distance, which is 10 miles. And remember, speed is equal to distance over time. Okay, so we're going to do speed is equal to 10 miles over our time. And it says she did it in 2 hours, so we're going to go 2 hours. Okay, so our speed is equal to 10 divided by 2, which is going to give us a speed of 5. And our units here are miles. Well, I can't write. Over hours. Okay, so miles and hours, so 5 miles per hour. Another way you can write miles per hour is 5 mph, 5 miles per hour. That help? What else do you need? You want me to do the next one? You got another one you need me to do? Number 16, cool. If, I'm going to erase this. I'm going to work over here again. All right, number 16, and I'll get to the graphs in a second. Number 16, if it takes a leaping Louis 5 minutes to jump 3 blocks, how long will it take him to jump 15 blocks? Okay, so we're giving our time here. We're giving our time and our distance. Okay, so we can calculate our speed from that. So we're going to have speed is equal to distance over time. So speed is equal to our distance, which she said was 3 blocks. And it took 5 minutes. Okay. So 3 divided by 5 will give us how our speed, which is 0.6 blocks per minute. Okay, and so we're going to write out blocks per minute. Okay. All right, so now that we know her blocks per minute, and it is asking us for our time. So it says how long will it take. So anytime it says how long will it take, it's asking for time. So we need to rearrange our formula, and time is going to be equal to distance over speed. Okay? And so remember, we can do that with our triangle. We have distance, we got speed, we've got time, all in our nifty little triangle. You can cover up time, and you'll see that it's d over s. So time is equal to distance over speed. And we found our speed. So now we're going to write out time is equal to our distance, which it says how long will it take them to jump 15 blocks. So we got 15 blocks. We've got our speed, which is 0.6 blocks per minute. Now we do that math. 15 divided by 0.6, and it's going to give us 25 minutes. Okay, so this is a two-step problem where you have to solve for your speed, then use that speed, plug it in, and solve for your time. Okay, so it gives you two scenarios. You find the first scenario, you solve it, you take your answer, you plug it into the new formula, that you rearrange the formula to now solve for the new variable that you need. So time is equal to 25 minutes, and we know that because it gave us the ability to solve for speed. We use that speed, and we find our distance, or our time now, with the new distance they gave us. All right, which graphs are we talking about? How do you do the graphs? Because I solved it two ways. There were multiple graphs. I don't know which ones we're talking about. Calculating speed, time, distance, number 6, and number 7. Is that the one with the bus? All right, I think you're talking about the one with the bus, so let's load up that one. And I made a key of this, and I promptly left it at school. And Aquino, oh, about the runners. Okay. I'll say Aquino was asking about those as well, and I was having trouble with them because apparently I forgot how to do it since this morning when I made the key. So I'm going to have to get back to Aquino on that one. But the runners... Alright, two people asking for two things. So pull up calculating speed, time, distance, number 6, number 7. It's the one with the word problems. And K9 is wanting the calculating using motion graphs about the runners. So this one's about the runners, right? And so 6 and 7 over here, 6B and 6C you cannot do. It doesn't make any sense. So those are gone. So just ignore those because you can't actually do them. And number 7, again, I did it this morning, and I somehow am second guessing myself every time I solve it. So I don't want to solve it right now. Let me get back and check my key, make sure I'm solving it correctly because I'm being dumb tonight. So let's go back to the word problems. These word problems or different word problems? The formula challenge word problems or a different word problem? Let's see, let me look through the handout. The word problems. The other one with the compass rose on it, that one has two number 6s, but neither of them are about runners. Is that the one you're talking about? See. Distance displacement on the back. This one? Distance and displacement worksheet. It's got a compass rose on it. It's got 2 pages. Speed on the back. And then distance displacement on the front. So 6 is about Jose buying a new moped. Is that what we're looking at? Otherwise, I don't know which handout you're talking about. Okay. Number 6 and number 7. Let's do it. Jose buys a new moped. Can I zoom in on this thing? I can. Technology. Alright, we're getting fancy. Jose buys a new moped. He travels 3 kilometers south, 4 kilometers east. How far does he need to go to get back to where he started? Okay, draw it out. I know you don't have graph paper. I'm going to cheat. I'm going to give myself some graph paper. Alright. So here we go. Come over. We are starting here. Okay. He goes 3 kilometers, so 1, 2, 3 south, and 4 kilometers east. 1, 2, 3, 4. Okay, so this is A, B, C. Cool. How far does he need to go to get back to where he started? So we are talking about from C going back to A, and this is what we are solving for. Okay, so that's our hypotenuse. It's also our displacement. So basically, all we're doing is solving for our displacement. So this was 3 down, this was 4 across. This is a right triangle, right? So anytime you have the 2 sides of the right triangle, you can solve for the hypotenuse using Pythagorean theorem, remember? So we're going to come over, we're going to use a squared plus b squared equals c squared. And so we plug it in, 3 squared plus 4 squared is equal to c squared. So 9 plus 16 is equal to c squared. That's 25 is equal to c squared. We're going to have to take the square root of both sides. And you're exactly right. C is going to equal 5, and kilometers is our unit, so kilometers. There you go. So when you're solving for the hypotenuse, all you do is use a squared plus b squared equals c squared, Pythagorean theorem. Make sure you match up your units. It said we were using kilometers, so I'm going to write kilometers in for the answer. And I cheated and gave myself some graph paper, but honestly, it doesn't really matter. You can just come over and know you can draw it like this, right? 3, 4, and you know what you're drawing, so you know that that's what you're looking for. Okay, and you can solve for that. You don't actually need the graph paper unless there's a whole lot of steps involved. You're pretty good. You can just figure it out just by drawing your triangle. Second page of that, number 6 and 7. Here we go. A bullet. Let's see. So a bullet travels at 850 meters per second. Okay, I'm looking at number 6 here, this guy. How long will it take a bullet to go 1 kilometer? So we're given our distance, right? So this right here is our distance. I can come in and write my D for that distance. That was really, hasn't been giving me that thick of a line before. Interesting. That's our distance. So this is our speed. And so anytime it says how long will it take, Okay, you guys ask this question all the time. How long is this going to take? How long will this class days? How long to the bell? How long till lunch? So on and so forth. You know that that's dealing with time. So we're looking at our time. So when we come over here, we know speed is equal to distance divided by time. And you can rearrange this, and we can use our triangle DST. Okay, draw your triangle. So we cover up our time. We can see that time is equal to distance over speed. So we're just going to plug it in. Time is equal to 1 kilometer divided by 850 meters per second. Now, here's the issue. Here's why this is a hard problem. This is in kilometers. This is in meters per second. Okay, so it's like math. You're going to have to convert from meters into kilometers. And so as we know, kilometers means 1,000 meters. So if it's going 850 meters per second, we're going to have to come down here, 850 meters per second. Okay, we're going to do our conversions. Okay, well, hold on, I messed this up. Since I already made, oh no, I hit the wrong key. Undo. Zoom in. We will save their mistakes. Okay, I want to erase this guy because I already drew a fraction. I don't need a fraction in a fraction. Okay, so that's meters over 1 second. We're going to move our meters down here to cancel it out and put kilometers up here. And we know that there are 1,000 meters in 1 kilometer. We're going to multiply through 850 that over 1,000. And we can see that our meters here, right, will cancel because anytime you divide something by itself, you get 1. So meters divided by meters cancels out. So this is just like in math when you're converting your units. It's the same exact thing. So this is going to be kilometers. This is going to be seconds. We just have to do that. 850 divided by 1,000. You just move your decimal place over 3 places. So 0.58 kilometers per second. There we go. Now we are in the same units. Okay, so 1 kilometer, and our speed is 0.850 kilometers per second. Okay, all right, so we just do that. Time is equal to 1 divided by 0.850. So we're going to do 1 divided by 0.850, and we're going to get our answer, which is 1.18. And our time is in seconds. There we go. So this one was a little bit hard because you had to match your units. So anytime you're reading through and you see your units do not match, you have to change them to make them match. And it's unit conversion. I do it with all of these. Where'd my laser pointer go? I do it with all of these fractions because it really helps me keep it straight in my head. So there we go. That's number 6. Number 6 is our wonderful 1.8 seconds. I'm having fun with my tools. Okay, number 7. You okay if I erase all this? Because I'm erasing all this. Goodbye. Every winter I fly home to Chicago. It takes 3 hours. What is my average speed? Okay, so this one is hard because how far away is Chicago? Oh, look it up. Okay, so Google Maps. I don't know, you can look this up on your phone. Chicago. Directions. Starting point. My location. Let's see, 730 miles. Okay, there we go, 730 miles. That's all we got to do. The worksheets are due on Friday, as I said on the board this morning. So the worksheets, I will check them on Friday. Okay. So we are going to say it's 730 miles away. That's our distance. Okay, distance is equal to 730 miles. It takes 3 hours. Our time is equal to 3 hours. And then what's your speed? So we know that speed is equal to distance over time. We just plug it in, 730 miles divided by 3 hours gives us our speed. So you just plug it in the calculator, 730 divided by 3 is equal to 243.3. And that is miles per hour, mph. That's it. There you go. All you had to do was look up how far away Chicago is. All right, what else you got? What else you need help with? Everything. Like, all the way back to distance displacement? Like, that far back? Or just speed? So displacement is kind of a toss-up. You don't always know when it's displacement. Okay, we can do that. So let's go back to this worksheet right here. Distance displacement worksheet. Now I cheated and gave myself graph paper. I can even make it dark graph paper if I really wanted to. But I don't. So, let's look. Let's just start at number 1. Let's just do a real quick one. Okay. So, she drives 7 kilometers north. So we want to start here. Go 1, 2, 3, 4, 5, 6, 7. Cool. Then she goes 5 kilometers east. 1, 2, 3, 4, 5. Now, distance is what we're looking at first. So this was 7, this was 5. Now, distance deals with how far you actually travel. So you start, Marilyn, we just did number 7. Are you talking about the number 7 on this worksheet, the speed? We just did it. I can do it again in a second. So distance deals with how far you actually travel. So she goes from her starting location, and then she travels 7, and then she travels 5. So distance is all you do is add up everything together. So 7 plus 5, hopefully we can all do that in our head. We got 12 kilometers. That should be easy. Okay, so distance really just, you find out all the different types of travel they do and you add it up. Displacement is slightly harder conceptually. So displacement is a vector, okay? So it only cares about where you actually go. So I'm pretty sure 8.6 is the correct answer. That's a straight line. Just believe, okay? Use your imagination that's a straight line. And we want to solve, because displacement is how far out of place you are, okay? So we started here, we ended here. How far away did we actually travel, okay? So it's how far is like the shortest route possible. So if you were a bird and you flew from the starting point to the ending point, there's nothing in your way, how far away is that? Okay, so anytime we are dealing with a right triangle, so we have our right triangle, we went up and over, we draw our hypotenuse, we want to use Pythagorean's theorem. Okay, so this is where our math skills come into play. Okay, we're going to use our math and apply it to our displacement. A squared plus b squared equals c squared. This is 7 squared plus 5 squared equals c squared. 49 plus 25 is equal to c squared. Where's my calculator? 49 plus 25 gives me 74 is equal to c squared. And then c, we take the square root of both sides. So we want to take our square root of 74. And it's 8.6. You're absolutely correct. So this one is easy because it's a very simple right triangle. They're not always that easy. Sometimes it's a little tricky, like if you end up back where you start, okay, they can make you read this whole long problem and all this different movements, and then all of a sudden she's back where she started. Well, your displacement's going to be 0, okay? Anytime you're looking for displacement, you need to look how far away where you started from and where you ended from, and everything is that's all we care about for displacement. It just so happens that a lot of the times we use right triangles for this, but you know, in the real world, it's not always you don't always go 7 kilometers north and 5 kilometers east, and it's so pretty and everything. But you know, you're looking at how far you actually go from your starting point to your ending point. So I'm going to erase this and we're going to look at another one. So you said 3, so let's look at 3. All right, on a fishing trip, Justin rides in a boat 12 kilometers south. Didn't we do this one in class? I think we did. So I'm going to move this over here so I have more room on my board. I'm going to draw this with my mouse instead of my tablet. Okay, 12 kilometers south, then he goes 4 west and 1 north. So here we go. We've got one bigger line. So we're starting here, right? So we're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 12 south, then he goes 4 west. So 1, 2, 3, 4. Okay, and then he goes 1 north. So 1 north, and this is where he ends up. Now, you want to find the ending point to the starting point, okay? So we are going to draw a nice straight line there, pretend that it hit, okay? And that's what we're looking for, okay? So how do we solve this? Well, I'm going to draw out my triangle. There's my triangle. Okay, so this was 12 down, but I am 1 higher. My triangle ends 1 higher. So my triangle is 11. Okay, and I'm going to do my a squared plus b squared. I'm going to put in 11 squared plus my b, which is from here to here. Okay, so this side. And we knew that he went 4 kilometers west, and he didn't move from there, so that's 4. So this is going to be 4 squared equals c squared. Now we just do it. 11 squared is what? 121. Yeah, 121 plus 16 is equal to c squared. So 121 plus 16 gives us 137. You take the square root of both sides. So square root of c squared gives you c. Square root of 137 gives you 11.7. So 11.7 is equal to c. So that's his displacement. That's the displacement. Now the distance they covered, you just add up 12 plus 4 plus 1 to get 17. But their displacement is 11.7. Okay? So anywhere you end up, if you're on a graph paper, you can draw your right triangle, and you can figure it out from there, or you can calculate it, you know, depending on what they tell you. Okay, so like, and they end up 1 meter away from where they started. Well, then it's going to be 1 meter for your displacement. Okay. Number 4, Tara goes on a camel safari in Africa. She travels 5 kilometers north. Okay, let's draw it. So for starting here, we're going to go 1, 2, 3, 4, 5 kilometers north, then 3 kilometers east, 1, 2, 3, and then 1 kilometer north again. 1, so here she is. So what's the distance? Well, you add it up. She went 5, 3, then 1, that's 9. So distance is 9. Where did I get 7? Where did I get 7? 5, 3, 1. Are you talking about the last one? No, I didn't have 7 in the last one either. It was 11.7 was the answer, Marilyn. 11.7. Well, you can ask me them in class. I'll answer them in class too. It doesn't just have to be on YouTube. Okay, so we have our, let's go back to Tara. She went 5, 3, 1. That's a distance of 9. Our displacement is from the starting to the ending. We draw our line. Again, I'm not a good artist. Just pretend that it hits. Just pretend. Okay, now here's our triangle, right? I drew it up. I can draw my triangle out to here and down. Or if you're feeling, you know, crazy, you can draw this way and up. Either way will give you a triangle. So this was 5, but it's 1 higher, so that's a 6. And this is 1, 2, 3 across. So we're going to do a squared plus b squared equals c squared. So we have 6 squared plus 3 squared is equal to c squared. This is 36. This is 9. 36 plus 9 gives you 45, I want to say. Yeah, 45. We know the square root, or the square of 7 is 49, so this is going to be slightly lower than 7. So we take the square root of both sides, and it's 6.7. So that checks out. 6.7, and it's kilometers. That's our displacement. There we go. Okay, that's number 4. Now, next one's number 5, right? This up. All right, Alex goes cruising on his dirt bike. Hope he wears a helmet. He rides 700 meters north, 300 meters east, 400 meters north, 600 meters west, 1200 meters south, 300 meters east, and finally 100 meters north. Oh boy. Okay, so this is what I mean, where displacement can get kind of crazy. Okay, what distance did he cover? Well, it says he goes 700 north, 300 east, 400 north, so on and so forth. It doesn't tell us that he travels without giving us distance, so all we have to do is add it up. Okay, so where's my green? Green. So we have 700, 300, 400, 600, 1200, 300, and finally 100. So 700 plus 300 plus 400 plus 600. Getting a little monotonous. 1200, 300, and finally 100. Okay, so 7 plus 3 is 10. That's 1,000. That's 1,000. So we're at 2,000, 3,200, 3,500, 3,600. So 3,600 meters is our distance. Okay, all we had to do was add it up. Now, this is where you kind of need graph paper to do this one. You don't absolutely have to have it, but it helps me keep everything straight. So we're going to use our graph paper over here, and it says use 1 to equal to 100. So where it says 700 north, all I'm going to do is draw 7. Okay, so I'm going to start here. Go 1, 2, 3, 4, 5, 6, 7. Okay, 700 north. 300 east. 1, 2, 300 east. 400 north, okay? I'm cheating because I'm on a computer, so I've got endless graph paper. 1, 2, 3, 4. 600 meters. 600 meters west, okay? So now I come draw 1, 2, 3, 4, 5, 6. And 1,200 meters south. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 300 meters east. 1, 2, 3. Look, that's where we started. We are really close to our start. And finally, 100 meters north. Whoop! Look at this. Look at this. 3 different colors. Look at this. Look where we ended. Dun, da, 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 da. We ended where we started. So, distance. All you have to do is add it up. Displacement. You just got to know that you end where you start. And when you end where you start with displacement, your displacement is equal to 0. There we go. Done. Got it. So the reason that this was easy for me is because I had graph paper. If I did not have graph paper, I'd have to put a little bit more thought into it. I could draw it just normally. Like I could draw it this and then over and down or whatever it was. Okay, I could draw it, but you got to know how far you're drawing. That's why graph paper, you cheat. It lets you cheat. Okay, was that it? Marilyn, did you ever figure out where did you get 7? Can you tell me where you were talking about? I'll go back to it. All right, wide open for questions. If you've got questions, now's the time to ask. I'm gonna stay here for about 5 more minutes, but if there's no questions in that time, then I'm just gonna head off, as you should too, because it's 9:30 and we have school tomorrow. When a graph hits 0, that means it's at where it started. So if we're talking about distance versus time graphs, absolutely. So distance versus time graphs, the 0 line is where you are observing from. And then, so if you're at 0, that means you're where you started. Yeah. So you have no questions about speed? Page 2 of this one? Speed, distance, time. We good with that? Just our little triangle. It's like V equals IR. Or density once we get to density. Okay, it's very similar. You know, you got 3 variables, you just plug them in. Plug and chug. Marilyn, there's a little bit of delay, so when you say do it, I don't know if you're talking about the last thing I said or if you're talking about what we said earlier, so I don't fully understand how to do it. Tell me what it is so I can talk specifically to that. You will find out tomorrow. We're going to do physical science, obviously. On analyzing motion graphs. Okay, documents. This guy. Number 7. Which object has the greatest acceleration? Okay, so the way that it works is we've got, a line down the middle, basically. So 1 through 7 deal with our position and time graph, and 8 through 13 deal with our velocity and time graph. So number 7, which object has the greatest acceleration? Well, so when we're looking at velocity and time, we know that acceleration is our slope, okay? So when we're looking at this graph over here, we know that the one with the greatest slope will have the greatest acceleration. But on 7, we're looking at a position versus time graph, not a velocity or speed versus time graph. So the difference is acceleration actually isn't on this graph, okay? So we have our position as our y, our x is our time, and we know that the slope of a position and time graph gives us our speed, okay? None of that gives us the acceleration. So how in the world do you find whichever one has the greatest acceleration? Well, we know this goes back to the definition. So you're going to have to take the definition of acceleration. This is why we went and analyzed the vocabulary so closely. You have to take the definition of acceleration, and you have to be able to use that definition and apply it to what we're talking about. So the definition of acceleration is the change of speed over time, okay? And so when we're looking at our position, we have our position, we have our time, and then we have our slope, which gives us our speed. So we're really looking at the change in speed. So if we're looking at a change in speed, then we have to look at a change in our slope. So here we have a constant straight line, that's a slope. Here we have a constant straight line, that's our slope. Okay, so slope is constant, but look at C. So we start out going kind of over, and then all of a sudden our speed starts to change. Okay, we started with almost no speed, and now we are going pretty fast. Remember, a steep slope means you're going fast. So we started at 0, and now we're going pretty quickly. That is a change of speed. If there is a change of speed, there must be an acceleration. It's the definition of acceleration. So when you look at this graph and you see a straight line, straight line, straight line, straight line, line that curves, the line that curves means there's a change in your slope, and slope is speed. Change in speed means there's an acceleration. So C will have the greatest change of acceleration when you're looking at this graph. How's that, Marilyn? That makes sense? Did I lose you anywhere? Cool. Now that's different when we look over on the velocity and time graph. Remember, velocity and time, change in velocity is our slope. So slope is our acceleration. It's just you have to infer what acceleration is when you're looking at the position and time graph. All right, so we are going to call it there. I will we will continue looking at these probably tomorrow. I'm taking these up on Friday, as I said on the board. If you have any last minute questions, you better ask now. Otherwise, at 9:35, I am shutting this down, and you should definitely go to bed because you got school tomorrow. School tomorrow. All right, we're calling it there. You guys go to bed. Do your homework for math. You probably have daily 5 you got to do. And make sure that you are ready to go in the morning. Goodbye.